Thank you very much. Thank you, sir. This is to give me a chance to present my presentation topics today here. Welcome to my presentation. This is Mohammad Jonad Hussain, and my ID is 09924100005131808, and my level is level 1. That means the first year, first semester. Today, now I will present here the presentation on the Norton theorem. Next slide, please. Now I want to discuss about the Norton theorem. So basically the first of all, the first question is what is the Norton theorem? So we know that Norton theorem is that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of a circuit source N in parallel with a resistor Rn, where Rn is the short circuit current through the terminal and Rn is the input or equivalent resistance at the terminal when the independent source are turned off. Here I show this two circuit. Thank you. Now, so no problem. So next slide. Calculating the Norton equivalent. So when I will calculate the Norton equivalent, and how I will calculate this. The first of all, I will follow the sum step, and the first step is to remove the portion of the network across which the Norton equivalent circuit is found. And step 2, mark the terminal remaining two terminal network. The previous circuit I have shown that, and calculate first the iron and calculate the Rn, and next show the Norton equivalent circuit. As we know about the source transformations, the Thevenin and Norton resistance are the equivalent, that is the Rn equal RTs. Note, the voltage source replace the short circuit and current source replace the open circuit. And this is note for when I will solve this problem that it need. So now here is the examples, and find the Norton equivalent circuit and IL of the circuit in the figure 1.1. I'm here showing a figures, and the first step 1, when I will calculate the IN and show that the IM the first step was the RL equivalent is this removed, and IN is the short circuit current, and is show that the first of all, sir, previous slide need some more time, please. I will show that said how to calculate the IT, because I need the total current, and then I will calculate easily the ion. So first of all, you see that IT is the equation, and ion equal is RT into R2 भाग RT plus R3, because of the both AB is you see that's the R1 and R plus R3. So next slide, please. Step 2. Now I will I calculate the Rn. Norton resistance. So with Rn means the Norton resistance. The Rn, I'll show here, the Rn equal R1 is parallel with R2 and R3 is the series connection. So you may, if follow this equation, you may calculate the Rn. And step 3, this is the Norton equivalent circuit. And I also a question, that's how I will promote the IL, as this is IL equal Rn into IN into Rn divided Rn plus RL, and will obviously mark the terminal A to B. Thank you. If any questions, you may ask a question, please. Thank you, sir. I finished my presentation, and this is my just.
Does anyone have any question to Mr. Junaid? Does anyone have any question? Okay, Mr. Junaid, you are telling about the Norton's theorem. Here you use the linear two-terminal circuit. Can you tell me what is the linear circuit?
Sorry, this is an linear circuit is a circuit which is not unchangeable circuit.
Unchangeable. Is there any input-output relationship in the linear circuit?
So if a linear circuit, if I apply the voltage, then it will be output will be the current.
Linear circuit is the circuit which output is linearly related to the input. That means if we increase the, for example, according to the Ohm's law, we know B equal to IR, and that means if we increase the current, then we will get the higher potential, or if we increase the voltage, then we will get the higher current. Okay. And
Actually, right, sir. This is.
can you tell me what is the basic difference between the Norton circuit and the Thevenin circuit?
Sir, the basic difference between the Norton and the Thevenin circuits. So when the source is voltage Thevenin circuit, and resistance is with the series. But Norton, source is current and resistance with the parallel. This is the main difference between Norton and Thevenin.
Okay. Thank you. ওকে, নেক্সট শামিমা, আমি আপনারটা দিচ্ছি, আপনি প্রেজেন্ট করবেন আর কি। আমি স্লাইডটা ওপেন করি।
Thank you, sir. May I have a chance?
Okay,
Give me a
just
chance.
proceed.
Bismillahirrahmanirrahim. RTM-sylhet Technical University. This is Ms. Shamima Khaditi, Department of Electrical and Electronics Engineering. My ID, last digit name 809, level 11. My discuss presentation on superposition theorem. Superposition principle. The superposition principle states that the voltage or current through an element in a linear circuit is the algebraic sum of the voltage across or current through that element due to the independent source acting alone. Step 2. Apply superposition principle. Turn off all independent source except on one source. Find the output voltage or current due to the active source using nodal or mesh analysis. Repeat step 1 for each of the other independent source. Find the total contribute due to the independent source. For example, use the superposition theorem to find output voltage in the following circuit. Next slide, please. Step 1. When VS source active, other source such as current is open and voltage source is short. Find the I in the circuit. Step 2. I as source active when other source voltage source is short and current source is open, and similarly find out the current, and last calculation the current and like I said, direction on and output, find out output voltage. Thank you.
Okay, does anyone have any question to Shamima? Does anyone have any question? Okay, Shamima, if there is a voltage control current source in a circuit, and if we apply the superposition principle, what will happen? Is the voltage control current source will be short circuit or open circuit?
Sir, again question please.
If in a circuit, if we have a voltage control current source, okay, voltage control current source, and in that circuit, if we use the superposition principle, what will happen? does we short circuit the element, the voltage control current source, or it will be open circuit, or it will be the short circuit?
That will be stray in the circuit.
If the independent source is present in a circuit, can we apply superposition principle?
Yes, sir.
You have mentioned here turn off all independent sources. Okay, the source should be independent source. If there is any dependent source in the circuit, then we can't apply, because the superposition principle applies only in the independent sources. And the next question is, if in a circuit there are 5 sources, how many times we have to apply the sources for getting any voltage or current? If there are 5 sources, in your circuit there are 2 sources. One is voltage source, one is current source. So for getting B naught, how many times you have applied the you have considered the sources? 2 times. So if there is 5 sources, how many times you have to consider?
5 times.
5 times. Okay. 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 Thank you. Next, Rubel তো আছেন? রুবেল রুবেল আছেন?
স্যার
তারেক,
আমি বলতে চাচ্ছি।
জি জি,
জি স্যার।
আপনারটা দিই। হ্যাঁ,
জি স্যার।
আপনার তো কত, 8 নাকি?
জি স্যার, 808।
জি। দেখা যাচ্ছে? তার সাথে দেখা
দেখা
যাচ্ছে?
যাচ্ছে স্যার।
জি,
স্যার দেখা যাচ্ছে। Bismillahirrahmanirrahim. Good evening. A warm welcome to everyone present here. Thank you for taking the time to join me for today's presentation. The topic of my presentation is Norton theorem. This is a fundamental concept in electrical circuit analysis, offering a simplified approach to understanding and analyzing complex circuit. I truly appreciate your presence and look forward to sharing insight that I hope will add value to your knowledge and understanding. Let's begin. Statement: any linear bilateral complicated circuit with multiple energy source and resistance can be replaced by a constant current source is parallel with the resistor connected across the load. Here the linear complex network, Norton equivalent circuit, current source iron and source parallel resistance Rn and load resistance RL, shown the slide. Iron is
hold on.
so next.
Hold on.
Yes. Now I explain step 2 solve Norton theorem. Identify the load resistance RL and short the load terminal of the circuit. Next, networks simplification technique. Determine the current flowing through the shorted branch. This current will be the Norton current iron, and now remove RL from the given circuit and replace the all active source with their equivalent internal resistance. Further, evaluate the equivalent resistance across the open ends of the circuit. This resistance will be the Norton's equivalence resistance Rn. Now draw Norton equivalent circuit comprising of IN in parallel combination with Rn across the load resistance RL. Then find the current through the load resistance RL using the next slide, please. Numerical implementation of Norton theorem. Consider the circuit shown below. For
Okay,
mesh 1.
Mr. Derek, I am asking you a question. Okay.
Yes, sir.
You know, what is the difference between the Norton equivalent resistance and Thevenin's equivalent resistance? Is there any difference between Norton's equivalent resistance and Thevenin's equivalent resistance?
Yes, sir. Norton equivalent resistance. Norton equivalent resistance, a current source, and that is include.
We are talking about the resistance. We are talking about the resistance. For example, in this slide, whatever figure you have mentioned in the left side, okay, here we have seen that there are 5 resistor is present. Okay, what will be the equivalent Norton equivalent resistance of the circuit? Is there any difference if we use Norton's theorem and Thevenin's theorem in that circuit?
Yes, sir.
Is there any difference between this equivalent resistance?
No, sir. Same.
Yes, that Thevenin's equivalent resistance and Norton equivalent resistance will be always same, whatever the circuit we have. Okay. The
Yes, sir.
difference is that whatever Mr. Junaid mentioned while he was presenting, that in the Norton equivalent circuit you will get the current source with parallel resistor, and in Thevenin's equivalent circuit you will get the voltage source in series with resistor. Okay.
Yes, sir.
Okay, thank you. Next, আমি এখানে করতেছি আপনারটা। নেক্সট হচ্ছে রুবেল আছেন নাকি?
জি স্যার আছি।
আপনারটা দিচ্ছি, হ্যাঁ, প্রেজেন্ট করার জন্য। আপনার কত ID 1 নাকি?
জি স্যার, জি স্যার।
আপনারটা দিচ্ছি আমি।
রক্সি জায়গা থেকে এটা আপনার নেই।
আচ্ছা, একটা জিনিস বলে নিই যে তারেক সাহেব, আপনার প্রেজেন্টেশন স্লাইডে একটা ইয়ে ছিল, কমেন্ট ছিল আর কি। সেটা হচ্ছে যে প্রেজেন্টেশন আমি আপনাদেরকে বলছি সমস্যা নাই, আপনাদের দরকার হলে নেট থেকে সার্চ দিয়ে ডাউনলোড করে ইয়ে করেন, সমস্যা নাই। কিন্তু আপনি একটা জিনিস মেনশন রাখবেন যে সাপোজ ওখানে আপনার নাম, ডিপার্টমেন্টের নাম বা ভার্সিটির নাম, এই রিলেটেড জিনিসগুলো যেন কোনো ইয়ে না থাকে। যেমন আপনার প্রেজেন্টেশন স্লাইডে নিচে দিয়ে দেখবেন যে লেখা আছে ইলেকট্রিক্যাল অ্যান্ড টেলিকমিউনিকেশন ইঞ্জিনিয়ারিং, ডিপার্টমেন্ট অফ ইলেকট্রিক্যাল অ্যান্ড টেলিকমিউনিকেশন ইঞ্জিনিয়ারিং। প্রয়োজনে ওইটা স্ক্রিনশট নিয়ে ওই অংশটা কেটে ইয়ে করবেন আর কি, ওটা বাদ রাখবেন আর কি। আপনি কপি করেন কিন্তু ওই অংশটা বাদ রাখবেন আর কি, প্রয়োজনে আর কি। ঠিক আছে? জি, রুবেল আপনি শুরু করেন।
মানে থ্রিগুলো করতে হবে নাকি স্যার? রিডিং করতে হবে নাকি স্যার?
মানে আপনি ছিলেন না তখন? না, আপনাকে আপনার
স্যার আমি
সুপারপজিশন থিওরাম না, আপনাকে সুপারপজিশন থিওরাম জাস্ট প্রেজেন্ট করতে হবে। আপনি যা বুঝলেন এখানে কিছু পড়তে হবে না, কারণ পড়া তো আমরা নিজেরাও দেখতেছি। ঠিক আছে? আপনি জাস্ট ইংলিশে আপনি যেটুকু পারবেন একটু জাস্ট এক্সপ্লেন করবেন আর কি। এত ইয়ে হওয়ার কিছু নেই, জাস্ট টেক ইট ইজি স্টাইলে ইয়ে করেন আর কি। ঠিক আছে?
জি স্যার। Superposition theorem state that in any linear active bilateral network having more than one source, the response across any element is the sum of the response obtained from each source. Consider it separately and all other sources are replaced by their internal.
Okay, just hold on. In your presentation slide, here we have seen the two voltage sources. Okay, so if we consider the voltage source B1, what will be the happening for the voltage source in the place of voltage source B2? Will it be the open circuit or short circuit?
Right side.
What will happen in the place of B2? Will it be the open circuit or short circuit?
রাইট সাইড হচ্ছে আপনার ওপেন আর লেফট সাইড হচ্ছে ক্লোজ হবে স্যার।
No. Here, what we have shown here that in the place of B2, it is just short circuited. Okay. We know that while we are applying the superposition principle, the voltage source will be the short circuit and the current source will be the open circuit. Okay. ওকে, আচ্ছা ঠিক আছে, আপনার এখানে আমি রাখতেছি, সমস্যা নিয়ে। এরপরে হচ্ছে আমাকে প্রেজেন্টেশন পাঠাইছেন কে? শাহিন আছেন নাকি? ও আরিফ সাহেব আছেন তোমার বাকি এখনো?
আমি আছি।
একটু লাইনে থাকেন আরিফ সাহেব, আমি আপনারটা দিচ্ছি। আচ্ছা, দেখা যাচ্ছে?
জি স্যার, দেখা যাচ্ছে। শুরু করবো?
আরিফ সাহেব, আপনার কথা শোনা যাচ্ছে না।
স্যার, আমার কথা কি শোনা যাচ্ছে এখন?
হ্যাঁ, বলেন।
হ্যাঁ স্যার, শুরু করেছি। আসসালামু আলাইকুম। Thank you for the presentation. This is my Ariful Islam. My ID number is 811. This is fundamental.
আপনি যেখান থেকে কথা বলতেছেন একটু মাইকটা কাছে নিয়ে বলুন তো, কথা খুব আস্তে শোনা যাচ্ছে আমার এখানে।
This is a fundamental concept electrical. I want to discuss about Thevenin theorem. Sir, শোনা যাচ্ছে?
জি 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 জি, প্লিজ কন্টিনিউ।
Sir, next page then, sir. Thevenin theorem. Thevenin's theorem simplifies the process of solving for the unknown value of voltage and current in the network by reducing the network to an equivalent series circuit connected to any pair of network terminal. Any network with two open terminal can be replaced by single voltage source and series resistance connected to the open terminal. A component can be removed the produce the open terminal.
Just hold on. Hold on. Just
circuit simulated.
Just wait. Mr. Arif, just wait for a second. Can you explain this one?
Thevenin theorem. We know Thevenin theorem. Two terminal, one terminal with load and a voltage source with series resistance, and we see we see R1 3 with parallelly R2. So R1 3 parallelly R3 equal. So next page. So next question. parallelly, we know this.
Mr. Arif, Mr. Arif,
Yes.
this is the example for the Thevenin's theorem. Suppose if we want to apply Norton's theorem in that circuit, then what will happen here? In the AB terminal, here, what will happen in the AB terminal? If we apply the Norton's theorem in that circuit.
Sir, AB terminal open source and voltage.
If we apply the Norton's theorem in that circuit, what will happen the AB terminal? Will it be the open circuit?
Norton theorem AB close and AB close and voltage source AP open and voltage source close, sir. Norton.
No. Here for the Thevenin's equivalent circuit, for the Thevenin circuit, you are just opening the AB terminal. Then whatever the voltage you get the AB terminal, it will be the Thevenin's equivalent voltage. And if we apply the Norton's theorem in that circuit, the AB terminal should be short circuited. Then the current passing in that short circuit terminal will be the Norton's current source. Okay. ওকে, থ্যাংক ইউ, সমস্যা নাই। নেক্সট শাহিন কি আছেন নাকি? শাহিন নাই, হ্যাঁ। আচ্ছা শুনেন, হচ্ছে আপনাদের পরীক্ষা সংক্রান্ত নোটিশ তো দেখছেন নাকি গ্রুপে?
জি স্যার, দেখছি।